our session on the Internet of Things, and what follows is a series of fundamental concepts on the Internet of Things which will help you get started with IoT. But before we begin, let's look at our agenda for today. So we're going to start out with introducing you to the concept of IoT. We are going to discuss why you need IoT, what is IoT, a few benefits of IoT, followed by a few features, and finally the very important 5-layer architecture of IoT. Then we're going to discuss Raspberry Pi. In this section, we are going to talk about why do you need Raspberry Pi, what is Raspberry Pi, a few hardware specifications, and the installation of Raspberry Pi. Also, in this module, we have a few demos, including the Raspberry Pi, a few sense hats, and a Raspberry Pi camera module. Next, we are going to discuss the top 7 projects in IoT. In this section, we are going to talk about the best projects that we found in IoT. Next, we're going to talk about IoT devices. Here we're going to talk about various devices which came into inception after the concept of IoT was introduced. Then we're going to talk about IoT applications. In this section, we are going to discuss practical applications of IoT in various domains such as healthcare, security, traffic, governance, so on and so forth. And finally, we are going to discuss all things career in IoT. We are going to talk about the job market, the opportunity, the salary in different geographies and experience, so on and so forth. With that, we come to the end of our agenda. Also, kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. So without much ado, let's get started.
What is Internet of Things? Now, to help you understand what is Internet of Things, let's look at an example of our mobile phones first. Okay, our mobile phones has GPS tracking. It also has mobile gyroscope. You have adaptive brightness which gets adjusted based on the light falling on it. You have voice recognition, and you also have face detection which identifies who is the user. Now again, iPhone X is coming with face detection. So again, these are a lot of features that are coming pre-built on the mobile as such. And most of these have a common interaction between them, because let's say one application can use all of these features. I can also have these features in itself being interacting with each other. Let's say based on a GPS location, my brightness could be adjusted, or based on the direction my phone is being held, the brightness in itself can also be adjusted as well. So there are a lot of features, but when they interact with each other, these features come together to bring in a better system than anything that they can provide individually as such. That's what Internet of Things is. It basically is a platform wherein we can connect everyday things which are embedded with either electronics, software or sensors to the internet, and this in turn enables us to collect as well as exchange between these things. Now, when I say things, it can be anything and everything. Let's say I have an internet platform wherein I can connect these things. If I take the example of my house, I can connect my lock, I can connect my AC, I can connect my lights, and all this can be managed on the same platform. Now, since I have a platform itself, I can also connect my car to this. I can keep a track of my fuel meter, I can keep a track of my speed limit, I can also keep track of the location of the car as well. Now, if there's a collective platform where all of these are connected, wouldn't it be great? Because I would love to have the AC on and set a cool temperature at my home by the time I reach back from office. If I have a platform that knows my preference and that keeps track of where I am and where I'm going to, then it can also identify that I'm going from work back to home, and my preference suggests that it would be best if there was an AC temperature of about 22 or 23 degrees centigrade. And this is something that is definitely possible through Internet of Things. Now this is just one of the examples. Now let's say tomorrow you come back home. It would be great if I wouldn't even need a key to unlock my door. My home system should be aware that I have come home and it should unlock all the doors that are needed. And now this can be done if my mobile and my home devices are connected onto the same platform. Based on the location of my mobile, it can identify that I am at my home. So it will automatically unlock the door and let me come in as well. These are some of the real world implications of Internet of Things. These are something that are already happening. But going forward, what we need to understand is that when I have a specific component with me which can do a lot individually, wouldn't it be great if I can collaborate this component with my system of different components and build a better system? This is what Internet of Things is helping us do. Okay, you provide a platform through which all these things are connected through the internet. So internet becomes the medium through which you're connecting all these components or things to a platform. Moving forward, let's try to understand why do we need Internet of Things. Now to help you understand why, let's look at an example. There's a patient at home. Okay, he's on constant life support wherein his status is being checked to a health monitoring system present on the cloud. Let's say at a point there is certain issue with respect to his health. Let's say there's some irregularity with his heartbeat or his blood pressure is low, there's some fluid being developed or so forth. Now what happens is, since the system on the cloud is connected to a hospital as well, this information would get passed on to the hospital as well. Therein what would happen is that they would get the complete details with respect to the patient and the important information with respect to the current situation of the patient as well. We made it aware with respect to what issue exactly is the patient facing, as well as enable them to dispatch an ambulance immediately to bring the patient back to the hospital as well. Now, meanwhile, once the patient has been picked up and brought back to the hospital, there could be prescriptions, there could be medicine, there could also be an operating theater made ready in case of an emergency situation as well. There will be doctors on standby who have the complete history of the patient, who have the complete details of the present condition of the patient as well. So this in turn brings in a lot of transparency and reduces a lot of effort and time involved with respect to this. Same thing, let's take in today's scenario, there has to be someone monitoring this patient's health. And if there's a fluctuation, they need to call the hospital, they need to call request for an ambulance. And meanwhile, once the ambulance is here, they take the patient and they're back into the hospital. Then again, there needs to be a lot of checkups that need to be done because the doctors are not fully aware. Again, there is a lot of tests that need to be run, and this in turn leads a lot of delay as well in certain emergency cases as such. Now, if a system can do this, then this is exactly where our future lies in and what we have to definitely move forward to. Now, Internet of Things basically is expanding the interdependence of humans to interact, contribute, and collaborate with things around us. Now, what do I mean by interdependence of humans? How we depend on each other. Like how I'm explaining this concept to you. If you're not clear, you would reach back to me, you would request me for help. Okay, this becomes an interdependence between us. When I'm giving you knowledge, when you're not clear, you're coming back to me and you're helping. Similarly, tomorrow, if there's something that you can do for me, I will reach out to you. So we all are interdependent on each other for something or the other. If we can expand this interdependence to interact, collaborate, and contribute with respect to the different things around us, then we would be building a proper Internet of Things environment. This would be a much more safer, secure, effortless, and time-saving environment in existence. Moving forward, let's talk about the various benefits of Internet of Things. Now, the first thing that would be as a benefit of having an Internet of Things platform would that it would efficiently utilize the resources that are available. If I have a smart system which can interact with everything, if it has enough computational power, if it has enough understanding of how things work between each other, I'm quite sure the usage of the resources available will be more efficient as well. This resource could be in terms of monetary, it could be in terms of natural resource, it could also be an input taken up by the thing as an input and so forth. Okay, so all this can be more efficient if I have a platform which is more smarter and interconnected as well. Apart from this, it minimizes the human effort involved. If my system is smart enough to interact, if it is smart enough to do things that I don't need to get involved with, then my interaction is always going to be minimal. This is the same with everyone. And that's one of the major reasons why Internet of Things has become popular today. And the concept of smart home is always growing as well in the same perspective. Because if the system in itself is able to do most of my work at home, then I don't need to put in much effort. I can relax at home without having to worry about anything. Okay, the next benefit would be it saves time. If it reduces my human effort, definitely it is going to save my time. Okay, apart from that, if the resources are utilized more efficiently, then again it is going to save a lot more time as well. All in all, any benefit of Internet of Things will in turn help you save a lot of time as well. Okay, so time is one of the major factors that can be saved. on an Internet of Things platform. Now, if I have an artificial intelligence platform through which all of this is managed and maintained, then the personalization and the human touch also comes into the picture. Now, today most of us have had a level of interaction with an artificial intelligence or a virtual intelligence as well. This could be a personal assistant like Siri, or it could be an assistance application like Google Assist. Now, if I have a system where all these components and things are interconnected, then in turn all the security present on each of these things is going to get multiplied, and it's going to build a much more secure system. Apart from that, the level of security that you will be integrating to the platform in itself is going to be quite huge. So the overall security with respect to everything is going to increase multiple times as well. Now let's look at some of the major features of Internet of Things. Now, any technology that is available today has not reached its 100% capabilities, and it always has that gap to grow. Internet of Things is one of the major technologies in the world today that can help any other technology reach its true and complete potential as well. Now, there are mainly three aspects to Internet of Things as to how it works. First is the connect aspect. Here, basically what you need to work on is you need to ensure that there's a connectivity between all the things around you, all the necessary things to the Internet of Things platform. Okay, then comes analyze. Now I have my things around me. They each are going to generate some amount of data. Now this data needs to be collected and it needs to be analyzed to build a business intelligence solution. If I have a good insight from the data that is gathered from all of this, then definitely I can call my system as a smart system. Finally, what happens is, in order to improvise and improve your system, you need to integrate it with various models to improve the user's experience as well. Let's say there's a personalization module that is there, or let's say there's going to be an aspect where I can directly connect to my providers. Now this provider could be Amazon, it could be Flipkart, it could also be my retail store that is next to me. Let's say I'm out of milk, the retail store will get a notification and he would send milk right away. And the same thing can be done. Let's say my coffee machine requires special beans and this beans is almost complete. Then what my system could do is it could go online to Amazon and purchase these beans for me as well. So there are a lot of things that I can do when I integrate this with respect to various models and improve the overall experience to a single user or a group of users or the world itself as such. Okay, now let's talk about each one of them one by one. Let's start with Connect. Now, the first stage of Connect is device virtualization. Because what you need to first do is that you need to standardize the integration of the device to the enterprise platform which is present on the cloud. Okay, now it could be present on a cloud, it could be present on a server, but again it's all going to be connected through the internet. So what I need to do is that I need to ensure that certain level of standard is present on the device so that it can go on and connect to my Internet of Things platform. Now, to help you understand this better, there could be a standard power plug and there could be a power plug which has an inbuilt Wi-Fi support so that it can connect to my lab. Now, to build a smart home system, I need the second power point because there only I would have the access to control it over the internet and my system could integrate with respect to the same. Okay, now if I take the first standard power point, then what would happen is that I need to manually switch it on and switch it off. However, in the second case, I could send a signal to it and this in turn will switch it on and switch it off. So there's supposed to be a level of standardization through which I can integrate all of these devices to my platform. Next comes high-speed messaging. So now what I have done is that I have connected all these devices to my platform. But these devices in turn generate a lot of data, and this data is what is going to help us understand better on how we can improve the overall system and help and provide the user with better experience. So for that we need to have high-speed messaging. Okay, this basically means that there needs to be a reliable, secure and a bidirectional communication channel between the devices and the platform. Now the purpose of it being bidirectional is because you need to control each one of them as well. Let's say I want to switch on the AC, then the signal would be going on from the cloud platform to the device. So this is how it works out. Okay, so every communication needs to be reliable, it needs to be secure and it needs to be bidirectional as well. Moving on to the third point of Connect, you need to have endpoint management. If I don't have an endpoint management, I've established a way through which all my devices can connect to my platform. I've also ensured that the data is going to be sent from the device to the cloud, and the cloud can send back to the device as well through a secure channel. But if I don't actually identify from which device which data is coming and how this data has to be processed, then it becomes a failure of the system. This is where endpoint management comes into picture. Endpoint management basically helps you in managing the device's endpoint identity, the metadata, and the overall life cycle involved with respect to these things as such. Okay, so to put it quite simply, it basically helps you identify from which device which data is coming and what needs to be done with this data as well. Now, coming on to the next feature is analyze, and the first thing that you need to do for analysis is the stream processing. Now, if the data coming from the device is not on a real-time basis, then my system is of no use. There's no use if I tell my system to switch on the AC at my home, and by the time I reach there, if the AC is not even turned on, then it's a failure on my system. Okay, so real-time analysis of the incoming and outgoing data must be done with respect to different aggregations, filtering, correlations, processing, and so forth. Okay, now apart from this, what you need to do is that this is raw data that is being streamed from all the things. You need to identify which is contextually important information which is going to be taken forward. So once I have the relevant information, then I can even generate composite streams of information which can be taken ahead for future analysis and understanding as well. Now this is what your data enrichment process does. Then you have event store. Now in event store, basically any information that you want can be queried and visualized from the vast amount of data which is present on my cloud platform. Okay, now this in turn can also help me get a better insight and analysis. If I have all the enriched data present on my cloud platform, I have a tool which helps me identify what is needed, helps me analyze this data, helps me visualize it, then definitely it becomes more useful as well. And when I have data coming from different things as such, this in turn can also lead to being a collection of big data. Now, when I talk about big data, it's not just few GB of data, it's going to be terabytes of data. Because the data generated from the things around us is that vast. And if you're doing it over a period of time, then definitely it is going to grow into a big data domain as well. Now, coming to the third feature of Internet of Things comes enterprise connectivity. So this is what I was basically telling you about. Let's say I have a requirement from my retailer or even an enterprise organization which is present. It could be Amazon, it could be Flipkart, anything as such, any enterprise organization which provides me a service. If I can connect to them through this platform, then definitely my overall process also becomes easier as well. Let's say there's a service provider. Okay, let's say there's a leakage in my plumbing, or let's say there's some issue with respect to my electricity. Then it can contact the corresponding service provider, it can send them a detail, and correspondingly they would be dispatched. This would in turn reduce my effort of having to check the problem, having to call someone, wait for them to come back. All that gets reduced to minimal required effort as well. Now, how does this communication happen? So for that, we have REST API. Okay, once I've integrated my REST API with respect to the cloud application and my Internet of Things, then communication between the enterprise, communication between the platform, and the communication between the things around us can be made more efficient and can be more easy as well. Now, the third aspect is command and control. If I don't have command and control on my platform, then it's of no use. Yes, I build a very great environment, I build something that's quite extraordinary. But if I cannot command it, if I cannot control it as per my requirement, then the system in itself is not useful. If I cannot tell my door in a smart home to unlock when I want it, then it becomes failure on my part. If I cannot control the AC on my smart home, then again it's a failure. So always the major aspect when you integrate with respect to these things, the major thing is that you need to ensure there's a huge control on the system and you're able to command it as per your requirement. Now this command could either be through a voice-based recognition, it could also be a message that you can send through your mobile application and so forth as well. When we come down to the IoT ecosystem, there's no single consensus, or again, there's no single architectural design that's out there which is agreed universally, because each company, each organization, each user for that matter has different requirements. And when we look down to it, we can break it down to a simple three-level architecture
wherein we have a perception layer where sensors actually gather the information from the environment around it. Okay, once this is done, I'm going to pass this information to the network layer. The network layer in itself takes up the responsibility of transferring this data from the sensors to the next layer, which is the application layer. Now here the main objective or the responsibility is the application in itself delivers this information to the end user or the end platform for that matter. This architecture can also be expanded to a 5-layer architecture. Now, when I talk about a 5-layer architecture, it's quite similar here itself. The difference mostly comes around with respect to the transport layer, the processing layer, and the business layer mostly here. When we had 3 layers doing the earlier task, we've just broken this down so that we have an easier operation or a smoother system for that matter. Now, again, the perception layer remains same when it gathers the information from the sensors, but the transport layer actually transports the data between the sensor to the processing center. Now, this could be through a wireless system, it could be through Bluetooth, it could be through RFID, 3G, NFC, or any medium that I choose to. Once the information has been transmitted, the processing layer comes into picture, which actually stores the relevant information, analyzes this, and again processes it as per the user's requirement. Now, again, this could employ various databases, cloud computing services, as well as big data processing modules to store this information as well as process it for that matter. Once this is done, I give the information to the application layer, which is actually responsible for delivering various services to the end user for that matter. On top of all of this stands your business layer. Now, any device for that matter, when it is working on a large scale environment, a business layer is usually used here. Now, let's say I'm working in an organization where we're using multiple pumps for different use features in different locations for that matter. A business layer here actually monitors the complete functioning of these pumps. You can also have these in various cars as well. So what I would know here is if a car is going to break down, then I also get an awareness with respect to that individual car, and it also helps me enable or helps me reach out to the closest customer care center so that it can assist the user. Coming down to how I can process it, again, this can be divided into 2 segments. I have my cloud computing based processing, wherein here it's quite simple. Once I have the information, I pass it on to the cloud platform, which then in turn also processes it and also has various applications to deal with this processed information for that matter. Now, again, this is something that I can do on a system which does not require any immediate action and requires a large amount of processing for that segment. But let's say I am in a system where I need immediate response. In those cases, I can go with my fog computing. Now, again, fog computing is something that represents a layered approach wherein we actually insert monitoring, pre-processing, and storage with the security layer between the physical and the transport layer. Let me just go back a few slides here to help you understand this. Now, if you actually look, my fog mostly comes between these 2 layers, wherein I add 4 new layers for that matter. Now, again, this is used in order to make a system quite smarter or effective with respect to it. Now, between my physical layer and my transport layer, I have a monitoring layer, I have a pre-processing layer, a storage layer, and a security layer. Now, to help you understand this, let's take a real-world example out there. Let's say I have a complete traffic system which is built on my Internet of Things. Now, let's say at one point there is an ambulance that has come to a first signal. I detect this, and what I do is that I allow the ambulance to move from this traffic signal by giving it a green light. But what you need to understand is if I'm using a cloud computing, this message has to be passed on to the cloud. This information has to be then processed, and then correspondingly a map has also to be created. At the same time, when I use a fog approach, what happens is that all the pre-processing and the storage happens on the gateway level itself. The information from the sensor goes all the way till the gateway. Therein, it actually pre-processes this, stores the relevant information, and sends this back to these corresponding sensors as well. So let's say if there's an immediate track that I can create to the closest hospital, I would highlight all the traffic signals to be green so that the ambulance can move smoothly as well. Now, security here is very essential because if I implement this, tomorrow anyone can actually try to manipulate this for their requirements as well. Imagine there's a high-speed police chase happening and the culprit uses this in order to move fast from the traffic signal. So this is something that is really essential. Although there is a pro to this, there's also a con, and this is how we try to overcome this issue. Now, talking about each one of these new layers, when I come to the monitoring layer, what it actually does is it monitors the power consumption. It monitors each of these resources as well as their response and the services that are running on these resources. Now, this in turn helps me monitor or gives me a complete idea of which are the services or which are the sensors which are working, where are the challenges, what is the power consumption, and how it works with respect to that same. Now, once I have information from these sensors, what you need to understand is that usually you work with thousands of sensors in a real world environment. Now, I need to understand which are the necessary information. So I'm going to do a level of filtering, I'm going to do a level of processing, and then I'm going to apply a level of analytics to understand what is needed and what is not from these information as well. Now, the temporary storage area is something that I use in case I want to store any relevant information. Let's say I'm creating a route today for an ambulance as well, and this is going to be stored in my temporary storage area. But this also needs to be used in future scenarios. So once I'm done with this usage, I can also push it on to the next transport layer, which can send it to any other storage system that is part of my environment. Now, as I said, security plays a very important role. Although my fog computing is something that makes my system faster, it should not be easily manipulatable. Now, in a cloud-based system, I have the assurance that it's not really easy to break down the security. It's quite hard, where there are various layers of security which are part of the system. But when I have a fog system, it's essential that this factor or the security which deals with the encryption, which deals with the privacy of the information, the integrity of this information is maintained. Now, there's also a very interesting variation of this which is called an edge computing system, wherein rather than doing all these operations after I have gathered this on the gateway, I can do it on the individual nodes or individual sensors as well with respect to it. So where I have edges, these becomes point for me to perform operations on the data that is being collected. So that's a slight variation of our fog computing system as such. Next, let's talk about the various taxonomy associated with Internet of Things. Now, these are the key concepts, or these are the key layers which are present with respect to most architectures that's out there. Now, as I said, this is a generic idea. Each person or each system that's out there requires its own level of customization, requires its own level of approach to solve that problem. But these always remain the fundamental layers which are included in all the architectures out there. First, we have the perception layer, which is usually the layer where we gather the information from the various sensors that's out there, or we use the various sensors which are required as part of our system. Then we have the processing layer, wherein we perform filtration, we summarize the data, we again do a level of analytics on this data before we decide to send this relevant data to the system that's above this. Now, then I have a communication layer. Now, communication layer is very simple, as in here we'll define the protocols and standards as well as the medium through which the information has to be passed from my sensors to my main system as well. Now, middleware is something that's quite essential here. What it does is that it creates an abstraction as well as it makes my system work much more smoother. Now, what you need to understand is that there are various components involved here. Middle layer really helps me integrate the information coming out from each of these sensors or each of these individual systems. Once it's present, then I can pass it on to my application layer, wherein I have various applications which help to improve the overall experience of the user as well as provide much more accuracy and efficiency to the information that's present. Now, coming down, let's talk about each layer one by one. Now, before I talk about the perception layer, what you need to understand is that one of the most important aspects of Internet of Things is context awareness. That is, what you need to understand with respect to the change of environment is very important. And this is extremely impossible without the usage of sensors as such. Now, sensors in themselves are very small in size. They again cost you very little, and at the same time they consume very little power. Again, there are various constraints with respect to the factors as the battery capacity and the ease of deployment as well, but let's not go into them as such. Now, when I talk about sensors, again, we have various types of sensors as such. One of the easiest example of sensors that can be seen on a daily basis is the sensors which are part of your mobile. You have a location sensor, you have a movement sensor. Camera in itself is actually another sensor. Your microphone, your light sensor. These are all various important aspects of your mobile that we use on a daily basis. Apart from this, neural sensors, medical sensors like the fitness bands that we use, healthcare bands which are used for heart patients, again environmental sensors which check the temperatures around the environment, make you aware of the changes, chemical or biosensors which are very useful on a daily basis as well. Again, infrared sensors are something that's quite common as well. When we talk about RFID, this is something that's really important, or this is something that really gathers a lot of attention with respect to it. RFID stands for radio frequency identification. Now, unlike a traditional barcode, it does not actually require a line of sight of communication between the tag and the reader. and can identify itself from a distance without even a human intervention or a human operation for that matter. RFIDs are technically of two types. We have active and passive. Active tags actually have some amount of power source associated with it, and passive sources do not have anything related to it. And when we talk about the RFID technologies as well, there's near and far. A near RFID reader uses a coil through which we actually pass AC current and generate a magnetic field. Now, when we generate a magnetic field, anything that comes in its vicinity, it registers with respect to it. Now, when I talk about a far RFID, it basically is a dipole antenna in a reader. Now, this again propagates in electromagnetic waves, and tags themselves also have a dipole antenna. Now, again, these are something that's used in various applications that's out there. Now, one key factor which is associated with the perception layer is an actuator. Now, when I talk about an actuator, it actually is a device which can affect a change in the environment by converting any sort of energy into another. Now, this could be a motor which is generating electricity. This could be a windmill which is converting the wind outside to you to a electric form as well. And these are just some of the examples that's out there. And actuators themselves play a very essential role in the perception layer. Now, the next layer that we have is the pre-processing layer. But before I really talk about the pre-processing layer, let's actually try to understand the limitations of trying to process everything that we have on the cloud system, which is part of our ecosystem. Now, when I talk about this, one of the key or one of the biggest challenges for me is mobility. Let's say my sensors are on devices which are in constant motion. Then it becomes a really high challenge for me to pass this information continuously to my cloud environment. Again, this could be through the challenge of transport layer. This could also be due to the challenge of power consumption associated with it. When my smart device or when my sensors for that matter are in constant motion or are in constant mobility, then it cannot completely pass all the relevant information onto the cloud. Now, this in turn actually causes a challenge for me to have some latency. This could also lead to a latency with respect to real-time processing of the information that it gets as well. Now, if I'm working on a critical system, then real-time information is something that I highly depend on, and that becomes a challenge as well. Now, if I really want to scale up, if I want to use a lot of devices, then my cloud computing system also needs to scale. But there's always a chance to increase the latency because I'm working with multiple sensors or multiple devices that's out there. Imagine today I have a system which just includes 1,000 sensors. But let's say in a smart home system, there's close to about 10 to 20,000 sensors associated with it. So this is just one small system. Imagine if I'm trying to build a smart city. In that case, there's going to be hundreds of thousands, millions of sensors that's out there. If my cloud computing system cannot process this on a real time, then there's going to be a high challenge with respect to that sake. And this is exactly where the usage of smart gateways comes into a picture. This layer actually helps me process my data on real time. It also helps me filter the data on based on the priority or the requirement and creates a local copy of whatever is needed or whatever needs to be taken forward. Now, when I come to the pre-processing layer or when I come to the features of fog computing for this matter, there's a very low latency because the information does not have to go to the cloud system wherein the processing needs to be taken up. It always is done on the gateway level itself. This information really is faster, as we've seen in the previous example about the ambulance. Now, I can also use distributed nodes wherein the information does not have to be, or the processing has to be on one single node for that matter. When I'm using distributed nodes, then I can also distribute the effort or the work that is needed as well. When I'm on a mobile environment as well, these smart systems can communicate with the gateways present in its closest proximity. It does not have to connect to just one single gateway. If I'm setting up gateways across multiple points in my city, then it makes it quite faster and more efficient. And this in turn can also lead to a real-time response from the gateway for that matter. Once I have a real-time response, then it is making my system faster. And as in the previous example, rather than just clearing one signal, I can clear an entire path for the ambulance as such. Now, once I have relevant information, those which are necessary or those which are really something that I need to ponder or I need to analyze can be sent to the cloud system as and when